let's start from beginning again. So can I do this? Yeah. So time series analysis in Power BI Desktop. That's my talk for today. The organizers asked me to put like my introduction slide at the beginning. Usually I don't do that. I stopped with having introduction slides since some years. I have this on the end, so we can just jump over and jump directly into the topic. And for this, I just reuse a slide deck I prepared for all the AI features available in Power BI Desktop. There's many of them, as we can see on this slide. And for this one, so like 2 years ago, I started with doing talks like that, and then I thought I can show all of those nice and cool features in 60 minutes, and it turned out that's just not doable. We can always scratch this and this and this. So since then, I tried to pick some special topics out of that. So instead of showing you specific features, I have now this title of time series analysis. So we'll see how we can use some of those, not all of those, but some of those features to do time series analysis. And I think time series analysis is very important because in almost any report, in almost any organization, I would say in every organization and in almost any report or analysis or dashboard, we are interested in some time connection, how this evolved over time. And this is what this talk is about. So let's jump over to the demo machine. So I have ordinary Power BI desktop here, and everything I show here is available in Power BI Desktop, so in the free version. So you don't have to sign in for all the features, except for some of the features. And if I show one of those features where this is not free, I will point this out. But by default, if I'm not saying anything, I'm not referring to licenses or something like that, everything is for free. And this is astounding because you can do so many things with Power BI Desktop. And it's free. You can just install it on your private laptop and start doing your analysis. Yeah, so let's start. So the first thing is that we need some analysis, and to start with, I always start with the Q&A visual. When I've seen this many years ago, when they introduced the Q&A visual, I was thinking, hey, this is cool for demos. This is really to show what's possible, but I will never use that. And it turned out I'm always using it. The Q&A visual, there's several ways to start it, but the easiest way is just to double click on the canvas. So if I double click here, I get this question bubble. Ask a question about your data, and then I can start typing. It's even suggesting questions. So it analyzed my data model and found out maybe top size ranges by total product cost might be interesting, or top sales numbers by top sales order numbers by total product cost. Of course, this system is agnostic, so it doesn't know anything about, in this case, AdventureWorks. It doesn't know anything about the organization or the business behind. So it just tries to find out what's statistically significant and come up with suggestions for that. And that's also true for some of the analysis we will do. I usually don't use those suggested questions, just start typing. So if I'm interested, for example, in the sales amount, I can just start sales amount. And if it's knowing what I'm talking about, then it will show me the sales amount, and then I can pick one. And if it's red and it's not really sure what I'm talking about, if it's turning blue, so this should turn blue, obviously it does not today. And then I can, for example, I'll ask further now it's turned blue, by date, for example. And again, there's several dates because this is not a really clean and nice data example, which I would pass over to other people. But this is like doing similar things with similar technologies. That's what I'm going to demonstrate here. And that's why I have like a trendline date and the ARIMA date and so on and so forth. Usually you would only show one date column, right? So this is my excuse here why this sample is not as clean as it could be. And if I press OK, then I would have expected, so something is wrong today, reseller sales amount by day. That's what I'm interested, yes. Okay, that's what I was looking for, because this visual is already smart enough to find out the date, and the date, where's the half here? So the date is a continuous thing I had to, I put on the axis, so it automatically comes up with a line chart. If I have categorical data, it usually comes up with a column chart. If this is location, then it would come up with a map, for example. So this is really, really cool. And as long as this bubble up there, I can do anything and change it. So I could like also for 2013, then I would get a limited list. So would apply filters on this list. So as long as this input box up there, you can change it. If you like it, you can just transform it, and then it's the standard visual as any other. So I could have created this also with the visuals and the fields and everything else. So that's the first thing. When we're analyzing by time series, we put the time, of course, on the axis, and then and other things. This is the sales amount in AdventureWorks, and it's really, really volatile. But what we can point out is like there's some peaks there, and what we can do, for example, I can right click on one of those data points and then ask for please analyze this and explain the increase. So it's offering to explain the increase. Why the increase? Because this data point is higher than the previous data point. If I'm like I would click here on point clicking downwards, I would offer to explain the decrease. But I know that I get some nice insights here. So I analyze and explain the increase. And then we get this dialog box in the middle of the screen, just a few seconds, and then we'll see, yeah, it was really fast this time. Then you usually see like this light bulb. And always when you see a light bulb in Power BI, it means there's a machine learning model behind the scenes built for us. So it's not trying to analyze to find statistical significant insights in my data. For example, it find out that like the increase in there was a decrease for United Kingdom, but all the others were increases. Or then it also found like something like the sales amount. So it's start at the beginning. Here's the analysis of the 58% increase in sales amount between December and January. And that's offering, for example, sales amount by date and employee national alternate key. Employee national ID alternate key. Of course, this is not very useful, but there's obviously some statistical significant information. That's why I'm coming up with it. I think I also find this by first name, dated first name. This is really dangerous. It could find something because it does not know that this is a name. And we have, of course, we have more than one employee with name Linda. So this is really unfair because now we're comparing like 5 Lindas with only 1 Garrett. And so it's not very useful. So please be careful with that. Everything it comes up with is like statistically significant, but not necessarily also practically significant. Why it's coming up with the thing? Because it's my model. So if I want to avoid any analytics by name, I can just turn this off by finding my employee table. And then this employee table, I see there's a lot of tables, a lot of columns in there. And for example, I can just hide the first name. So if I just hide it, then Q&A, so it's hidden in here. It's still there. So if you have reports built on the first name, if you have tax measures using the first name, they still work. It's just hidden. And this means if I now click again on analyze and explain the increase, that the list with the first name will not appear here. So United States and first name is removed from here. What we also find is like one sales amount by date and gender, and this is something which can like be interesting. I mean, here we only have binary gender, so there's like really an old database. So sometimes now we have like more than one gender, of course, but this is still binary gender. And then we have this information, but we can see that there's an increase. There was an increase, of course, that's what we're looking for. And it found out that like the majority of the increase was by males. And this is where sometimes can start off discussions. People say, yeah, of course, because if you have more male salespersons, of course, if the sales increase in total, of course, also the portion of the males increase, right? So this is interesting why Power BI even comes up with this suggestion. And when we change the look and of this analysis, so there's also this portfolio. I'm not sure when to use this. Never found any use case where I could use this. But there's also this 100% stacked bar chart where we can see that in December the majority was indeed by female. So whatever the reason was, but our female salespersons in December sold more than the males, and this shifted then to now the males are selling more. This could be interesting. I mean, we don't know. Maybe I have to dig in there. And what you can then do is that you thumb up or thumb down. This only gives feedback to the product team. So it does not change the probability of this is coming up more often or less. But we can also click on this plus symbol. And if I click on this plus symbol, and I just get this this nice insight as a visual on my screen here. And again, this is just a normal visual. That means I can change it. And maybe you are also on the conservative side. So I like to have the females in red. Really, really boring. I know red, the females, males are blue in here. And then we can have like a line to emphasize the 50% because sometimes it's not really showing up the 50% here. To make sure, I can have an analytic line and add here one at 0.5. That means we get this 50%, and then everybody can see that like the majority changed. So this is really, really cool and easy to use. play around with this feature, because in many occasions you will find, of course, things which are not useful, not practical, but believe me, all of them are statistically significant. And there might be some new insights into your data you never knew about. So this is one of the things we can have here. Another thing is we can also sum things up. So for example, like with the Q&A visual, I just typed in a question, show me the sales amount by date. I can also have like a summary of what I'm seeing on the screen. So I have this line chart, and Power BI is capable of giving me a summary in plain English text. So there is this, where is it? It's this one, the smart narrative. So if I add the smart narrative to the screen, it will now analyze what's showing up here, and then it will create a plain English text. Sales amount trended up, resulting in a 600% increase between 1st of December 2010, which is like here, and Friday, November 1st, 2013, which is like here. And sales amount started trending down, and so on and so forth. So this is also really, really cool. And everything you can see in this green underline means this is not static. So if the data changes, if you refresh the data, also the content of those underlined content is changing, and you can even like write your own things here. So you can like have your own text, and then for this text you can also have like your own measures. So you can add, for example, sales amount for bikes was, and then let me find out where is this nice value thing here. We can add a value here, and then I can ask for sales amount for bikes in 2013, for example. And then we get this, and then I can add this as a value. So sales amount for bikes in 2013 was this amount, 26. So this is a really, really cool feature. So you can have your summaries, and those summaries will change according to your changes in your data. Other things we can do here, if I just duplicate this, so if there are any questions about those visuals, please come forward with those. Another thing we can do, we can duplicate this page here, and then I get rid of those two insights here, so we can concentrate on the sales, on the volatility of the sales. This analytics line, we can also have, for example, a forecast and a trend line and anomalies. So let's start with forecast. I can add a forecast here, then I can ask for, please, for this forecast, I want it for the next 6 data points. As I'm having monthly data, 6 points means 6 months, so half a year. I want to ignore 0 of the last points, and the confidence interval might be 95%. That means like it will come up with a line here, but of course, I mean, this is a forecast. There's not a high probability that we exactly land on this forecast, but there's a certain probability that we are around this forecast. And the higher the confidence interval is, the higher the bandwidth is. So within a 95% of chance, the true value will lie within this band. Give me a second, this will be better in Zoom. So seasonality, I would assume that like with monthly seasons, so we sell more on Januaries, in all of the years, and less in February's maybe in all of the years. So this would be seasonality, and we can just apply this, and then we get this nice pattern here. And if you look at this, I mean, there's a certain probability. Also, my gut feeling tells me if it's always moving down like this, it will also move up and down like this in the future. If you take a closer look, and we'll discuss later again how this is working. So as you see, we can like parameterize some of the options here, but we cannot really decide on the algorithm. But what all of those time series prediction, this forecast algorithm are doing is that they try to find patterns in there, and we'll discuss this later. So obviously it found an upwards trend because like the numbers up there are certainly higher than the numbers in this region. And obviously it found also a pattern. And if you look at this, this looks like an M-shaped pattern. So M is not really finished. As my first name is Markus, I easily can spot M anywhere. And you can see like this M-shaped pattern starting in, where is it? In November. There's also an M-shaped pattern starting in November here, right? And there's an M-shaped pattern starting in around December, November here. So this is just, it found this pattern and applied it to the prediction and applied it to the future, and that's what's giving us the prediction. If you need this more flexible, I will show you other ways where we can have more flexibility about what kind of algorithm is used here. And Very similar thing I would say is this find anomalies. So we can add anomalies and ask for a certain sensitivity. So if I increase the sensitivity, it will with a higher likelihood find anomalies. And if you think about what is an anomaly is something which was not expected. So the question is then, what was expected? And this is easy to do because if you can do a forecast, you can also apply this forecast just to the past. And as you can see here, if I like change the sensitivity, this is like the confidence interval. So like these bands, these ribbons are getting bigger. The smaller, so the higher the number, the smaller the so the higher the sensitivity in this case, the smaller the bandwidth. And this means that we tolerate not so many deviations. And if a deviation is really out, so maybe let's return this to, I think 90 is a good value. So we can still see this bandwidth. So for some reason, this algorithm expected that there will be a downwards trend between, what is this, December and January. But instead we got an upwards trend. So we sold more there, and this is an anomaly. So something not expected. Again, maybe you did expect it because you have more knowledge, because we did a certain marketing event or whatever, or shared vouchers or whatever. But just looking at the data, this would be an anomaly. And you can even click on this data point, this anomaly, and then it will again repeat what's happening here. So the sales amount was unexpectedly high because it had a value of 4.2 million above, and this is above the expected range of 2 million to 2.3 million. And it tries to find out what's different here. So obviously status current, this is something from the product table. There was a difference in here. Style is U, so products with style U were sold much more than expected. And also the marital status, that means if our employees are single or married, this also had an statistically, we can see there's like a significant influence on that. If this is the real thing, again, this is something you have to then decide. This is still on your own. This tool does not take away the decisions from you. Instead of the anomalies, I can remove the anomaly, and we can just have a plain trend. So a trend, so we can remove this again. A trend would be a straight line. And again, this is even simpler as the other ones, because with the forecast and the anomaly detection, we could at least like provide some of the numbers, like how long is the forecast and so on. With the trend line, there's only optical things. So we can have like the color, transparency, if it's dashed or whatever. But not really influence the kind of how this is calculated. If you click again, this is the green line better. But trust me, this is a simple regression line. Maybe you can remember there's like different mathematical formulas where you can find out the parameters for the simple regression line. And this is what applied here. If you just need a straight line, very good, you're done with that. If you need more flexibility, and this leads me now to the next chapter in this talk, we can of course do this by, for example, providing our own formulas, how to calculate this. And one fun way, I mean, this would not be my first idea, but I found a blog post from Daniel Maslyk. If I've never heard from him, please check out his blog post, because he implemented the simple regression line in DAX. So we just add this here first, so we can see this is exactly the same number. Now you see this blue line, simple regression line. And if I think if I zoom in, you should be able to see like there's a blue line and there's this gray dashed line just underneath or on top of it. So this is the very same thing. So that's why I know, because I know that the DAX measure is a simple regression line, so we can get rid of this, and then we can take a look on that. Not sure how confident you feel in DAX. This is a long DAX statement. Again, this is from Daniel Maslyk, and I linked his blog post here. I tweaked it a little bit because I wanted to try things out. So currently, we just emulated the very same thing we could also get with the trend line. So if you need just this straight line, please use the trend line. Don't bother to write and maintain code in DAX for that. But as we have the code here, we can now tweak it and change things. And before we do that, let's take a second to walk, so I can walk you through the code. Maybe we start at the very end, because this is more clear what we're seeing here. So what we're going here is that we have, this is the formula for the simple regression line. So we have an intercept. That's where the simple regression line is crossing the y-axis. That's the intercept. And then we have a slope. That means a positive slope is an upwards trend. Negative trend would be a downwards trend. And the higher the absolute number of the slope, the steeper the line is, right? And then the slope is then multiplied by date. So that means this is for every day or month or whatever my currency for the date is. I then increase at a certain amount. So this gives like the angle for my line. So the question is, how do I get the intercept and the slope? And this is done by variables. That's why there's this code is so lengthy. And variables are your friend. If you're new to DAX, variables make your code longer, but it's more self-documented because now I can refer to what I'm returning here. So I have this variable red, which I return here. And the important part is this one. And so now I understand what's happening. This is like the formula of my simple regression line. So now the question is the intercept. How can I calculate the intercept? Again, this is a variable, and this variable is then the average of the y minus the slope times the average of the x values. So again, what is the slope? Again, a variable. The slope, this is this approximation of those parameters. Like you take the amount of the number of values you're having, multiplied with the sum of x times y minus the sum of x times the sum of y. This is just a formula, and you will find this on Wikipedia and everywhere. And then you take this amount and divide it, it's the divide function, by the other thing. And then you have all this explanation. So what's the average of y? That's the average of actual values on my y-axis, the y-axis, right? And that's the average of x is the averages of my x values. And don't get confused. This average x means it's not referring to y or x. This is just the name of the formula. It's like an iterative function. And what the actual values? That's what we get here. So we have like a filter. So I'm not showing everything, but I'm removing any existing fields on the date table and then return my date and my amount and rename it here because this is like a select column, so I can rename the things here to actual x and actual y, and that's what I'm using down there in the values. So for example, if I don't want this line for all of my values, I just wanted to like only the last portion of my time period, I can just go there and introduce this filter here. So this should be, let me think. Is it just this? I think I have to remove those. So I only want to have the distinct dates, and I want to have only for the dates starting 2030 because that's my last year in this demo. Let's see if this is
got
right.
time for a question?
Of course.
Sorry. This is back to anomaly detection. So when you review the anomaly detection results before using the forecasting feature as a confidence check in the forecast pattern.
Yeah. Is this the question or?
Yeah, I said, would you review the anomaly detection results before using the forecasting feature as a confidence check?
Would I use that? I mean that's the same thing. So if we go back to where is this example? This is this one, the page 1. Yeah, so more or less my confidence interval and the anomaly detection sensitivity is just the same thing. So what's called in the confidence in the forecast, I have this confidence interval show me the bandwidth, and the higher the confidence, the higher the bandwidth is, right? And with the anomaly detection, it's just the other way around. So I'm not a statistician, but that's what I assume from what I see here, that the sensitivity is just like the confidence, like 100% minus the sensitivity, minus this percentage, which gives me then the confidence interval. So the confidence interval is like 100 minus the sensitivity or the other way around. Because if I increase this sensitivity, you will see that now this bandwidth gets smaller. So this is just a reverse function of my, I have to click, I always forget to click the apply. If I increase this, that like the band gets smaller. So this is like just the other function of the confidence interval. Does this answer the question?
Trying to see if she replies back. I'm not getting a reply, so I'm going to say yes.
Okay. Any other questions while we're waiting on the response?
She said that was helpful, so.
Okay. Very good. Very good. She doesn't say that I answered the question, but it was helpful. Okay. So now I changed now this the filter in this DAX statement. Remember, that's where we stopped. So now I have this DAX statement, and this DAX statement gives me the flexibility to change things. And what I changed here, I changed the filter there. So currently previously, I only showed those dates where I had a current sales, where the reseller sales count rules were available. And now I just changed it to like greater equal to 2013. That means now the line starts in January 2013, right? And it's going to all my times I have in my date table. So now this is like also a poor man's version of doing a forecast, but just forecasting with a straight line. Or I could apply a filter. That's what I did in the other one. You can also do it here. We can also, like, if I'm now showing only the data from 2013 onwards, maybe it's also a good idea to apply a filter in my given data. So like the trend line is only analyzing the data available since January 2013. That's not a must, but I'm flexible in doing that. So I comment out this all selected thing. And now I have a filter here where I say the date must be greater equal than 2013 January 1st. Like that's the same filter that we had down there. So I didn't discuss this filter, right? So I changed the filter here for the date must be greater or equal than January 1st in 2013. And the same I do now for the given data. So the actual values are also now filtered to only starting from 2013.
Okay, while you're here, before you actually change things this time, you could use a date slicer to modify the native trend line without the need to modify the DAX code, right?
Of course, but if you do that, then you narrowify the whole line chart, right? So the line chart will only show a certain amount. In my case, I only had the filter applied in DAX. That means I still have like the full line chart, but only the calculation was shown for a certain period. Or now I even changed it that also the calculation of this trend line, and this is the bad news. Within 2013, we have a downwards trend, and now like this prediction of the line chart is now down also based on the data only available in 2013. And overall, we had a downwards trend in there. So of course you can have slicer, but the slicer would also change the actual. So the green line is the actual numbers. It will also change what's seeable here. So it's totally up to you what you need in your visuals. Okay, does this answer the question? And by the way, this is called the Simpson effect, the Simpson paradox. Nothing to do with Homer Simpson, but a mathematician. I think he died in 2019 with 96 years old. And he discovered this effect that like in a whole data set, you might have an upwards trend, but within this data set, there might be downwards trends in there. And this is paradox because, I mean, if it's going upwards, you would expect it's always going upwards. But obviously, this is like, yeah, this is demo data, but this can also happen in real life data that like within the years, we have downwards trends. And we can do this the very same, we can check this out. Within the years, if only limit to 1 year, then we have these downwards trends, but over the years, we have an upwards trend. And I can remember, I think I discovered this Simpson paradox within the COVID discussion, and I'm not going into this discussion here in this talk, but there was like one effect that like some of the cities like had downwards trends, but still the general effect was upwards, or the other way around. And I thought, how is this possible? And then I found out there's even a name for that, Simpson paradox. Okay. I see your name blinking, Tracy. Are you talking to me? It's just my...
Well, they were asking what the paradox name was again, but then you said it, so I was asking them, did they catch that before I asked you again?
Okay.
So they said
this is what you could do in DAX.
They found it.
Simpson. Yeah, exactly like Homer Simpson, but I can't remember the first name. Yeah, so that's what they could do in DAX. I mean, DAX would not be my first decision here. Maybe we should reach out to smart visuals. That's what we also can do. So I can, again, let's copy and paste just this one, duplicate the page. And there is a bunch of course, standard visuals, but you can always click on this ellipsis, this ... and get more visual and then reach out to the marketplace and download different other visualizations. And I already did this, so let's find the right one. I want to start here. So for example, there's one available for forecasting. Let's see if this is a useful one. So I downloaded this, and basically this is running our code within this custom visual. So this visual is then analyzing the data, trying to find patterns and do then the forecast. And sometimes this is working or not, depending on what we're having here. And depending on the concrete visual, you might have seen different forecast settings. So I'm not playing around too much with those. So I already had this, for example, in what's a good one? Like this one, the time series forecast chart. This is the other one. I think this is this one, the forecast. Is it this one? TPDS. This one, forecast. No, it's exactly the first one. And I already squeezed this. So like I provided it with the with parameters. So I played around what kind of parameters does make sense for the data given, and then I get also this pattern. It looks a bit different at the forecast we had in with the built-in analytic line, because the algorithm is different. And what's the right or wrong algorithm? What's the right or wrong forecast? That's hard to say. You have to wait and then compare the numbers. So this is, of course, self-service. This means if you want to do a forecast for yourself, I'll provide this for others. Very, very good. What I did for one of my customers is that we had like R code running as part of the ETL process for our data warehouse, and we persisted the data there. So the tools didn't have to calculate the predictions, but we already provided them from the data warehouse. And we did also, what we also did is like we did like this forecast. We did every day, we did a forecast for the next 180 days. So that means for a certain day, we had like the actual day and 180 predictions, because like 180 days ago we did a prediction for this day, and 179 days we did a prediction for this day, and then we compared and could also learn how this algorithm works or not, or if you have to squeeze it and set different parameters. So there's lots of possibilities. Time-wise, I'm half on time. Okay, so that means this would be like the next thing is much more, the custom visuals are much more flexible. So they offer more of those things. There's several of those available. So reach out to the custom visuals. If you want to do this and need a little bit more of flexibility, and you don't want to write DAX statements, right, for this, but you get more flexibility, but still not everything. So maybe if you look this up, I think this is only available in the app market. So let's open up the app market. So the description of those packages. So if I look for forecast, so this should be, I think this is this one we're just seeing. Then there's this description what it's doing, and it's also telling you that's like using R packages. So if you download this and start the first visual, it will ask you, you have to install R and R packages to run this, but you don't have to write any R code. And it will also tell you how this algorithm works and what kind of things, how this is done. So maybe this is good enough for you, but maybe you need even more flexibility, and then we could write our own R visuals. So if you take a look, so I take again, copy and paste this visual, this one, duplicate the page, and instead of having this running, I can just change this to an R visual, so R script visual or Python. And I'm sure you do not want to see me typing R code here, so I'm coming prepared with a script, and I will just start the script, copy it in, and start a visual, and then I will talk you through the script, so what the script is doing. And we need a forecast. Let's start with trendline. Maybe this is the easier one. And if I click here on this one, then we see there's like this editor down there, and this editor, R script editor, provides me to enter a script. So I could write a script here, and it's reminding me how this works. So the following code is to create a data frame and remove duplicated rows is always executed and acts as a preamble for your script. And I see data set, and then we get this left assignment, data frame, undefined, and sales amount. So this undefined is obviously, it's good to really find out what the date in the year is and the sales amount. And then we have this data set and the unique data set. So what I see here, I think I have to change this from I still have this hierarchy in here. I don't need the hierarchy. I want the real date. So that's what I want going to see here. And if you change something afterwards, it's not really showing up. So it's not reflecting the changes. But now we have the date in here. And that's what my script expects. And then you could start typing here. Remember, this is a comment. So if I remove this, still it does the same thing. So it's providing me whatever values I'm having here as a data frame or a data set in R. If you've never heard about R, a data set is more or less a table. What you know from a Power BI table. Power BI table has different columns, right? Different rows, several rows. Every column in every table has one certain database, and all the rows have to conform to this data type. And the same attributes also our data sets and data frames in R have. So I can now go there and copy in my code for the trend line, for example, linear regression. This is this one. This means now I have to or I can write R code. So this is like advantage and a disadvantage on the same thing. So if you are able to understand this code and change things, you can do a lot more than you can just with the custom visuals, or you can just with the analytic line. So this gives you just more power, more capabilities, but it's also meaning that you have to learn, for example, writing scripts in R or Python. We also see a Python script afterwards. And if I make this smaller, then we see that again, we have like this blue line. This is the actual data, exact same thing we already have seen. And then I use the blue line for this trend line. So how is this built? If I open up this, then we can see that the first thing is that I'm loading libraries. So libraries in R as a language is open source, and also libraries, most of the libraries are open source. I'm not sure when I looked it up the last time, but I think there were like 13,000 or even maybe it's now over 14,000, I don't know. So 14,000 different libraries. So this is huge. If you're beginning to learn R, this is overwhelming because all of those packages have different functions, maybe more than one function, and it's just impossible to get an overview. But it's open source, and there's common packages I would start with. And if you come to the limit of these packages, then you do research and find another package where you can then solve this problem better. So what I'm doing here is I use two packages. One is ggplot2 and the other one is scales. ggplot2 is grammar of graphics. So GG stands for grammar of graphics, and that's plotting. And yes, it's the successor of ggplot, and ggplot was just Hadley Wickham just began from the beginning again and just began with a new package instead of maintaining the other one. And scales helps me to get these nice numbers because R is the successor of S, and S is a statistical language. And the mathematicians usually use like this scientific notification, like 4E06 means 4 times 10 to the power of 6, which is 4 million. That's what statisticians usually use. But for me and my clients, it's better readable in this format that the scales package helps me here. Tracy, do you want to say something?
Yeah,
Okay.
Someone asked if you can use a Python script in this visual.
Yes, not in the R visual, but in the Python script visual. So maybe I go through the R script, and the next will be we do the very same with the Python script. Okay?
Okay, thanks.
So then we have this data packages, and sometimes you have to prepare things. Usually I prepare everything, of course, in Power Query, but I found out like most of the packages like to have a date in a certain Unix timestamp format, which is the POSIX-CT format. So that's why I'm converting this. If you're not converting it, it still will work, but you usually have an easier life with all the packages if it's in exactly this POSIX-XCT format. And then I create a plot. So there's this ggplot function, and I'm passing over parameters. So dataset, remember, this is what we just got from Power BI. So Power BI exposes the date and the sales amount in an object called dataset, and that's what I'm referring to. And from this object dataset, I then ask, please put as the aesthetics on my chart the date on the X value and the sales amount and the Y value. And there's a blank in the name here. You see there's a blank in the name. I have to use this get function and pass it in double quotes. That's the only issue. And I want to have the line and the dots points in green, which is the third color in my color palette I'm using here. I'm increasing the text size to 18. I want this y-axis to be a continuous axis with limits between 0 and 5 million. So even if like apply filter, I do not want those axes to change because then like it's hard to compare things. I disable the position, the legend, and then I have these labels here. So the date, the text here, date and sales amount. Not sure if you can read this. As soon as I will close this, you should be able to read this as the text from here. And the ggplot package already has the statistic smooth function where I can ask, please use the linear model, which is a simple regression line, and show me the line there. And I could, for example, change this to less, and then we get not a smooth line, but a local regression line, which is a curved line. So this is a possibility you have if you have scripts, because then you can change the scripts and apply different things. Before I jump over to Python, I usually don't write anything in here, but in Power BI, you can also tell Power BI not only where to find R, but also where to find a good R editor. So with the press of this button, Power BI will now take the content of my R script visual and pass it over to RStudio, because I told Power BI RStudio is what I use to write my R code. And it's not only copying the things over, but is adding these 3 lines. So like everything from here, this is just the code I walked you through. Exactly the same thing. And the first 3 line, there's this data set equals v CSV. So what Power BI does, it takes whatever I currently see in my visual in Power BI, export it to a temporary CSV file locally on my disk. So C user, Ehrenmüller is my username, a CSV file, and adds this line. So if I now run the whole script, I can see the same chart with the exact same data. And this is a really, really, really cool feature, because as soon as this is finished, I should see my chart in here. Does this run? Did I execute? I did execute. GM smooth. There's some demo effect apparently, because I should see my chart in here. So the plots, yeah, here's the plot. Okay, for some, it did not jump over to this chart. So I see the very same thing. So I want to now change anything, I would do it here in this editor and see the results. And if I'm satisfied, then I copy over the whole script except for the first 3 lines. So this is a really cool feature. And this is also what could be nice for data scientists, because cleaning up data in Power Query is much easier than writing your scripts in R. So you could combine like loading the data with Power Query and then use this feature to make a CSV file out of that and then work further in R. So, and then there was the question, what about Python? Of course we can do Python. And there's always these discussions like, I don't know, like Mercedes and BMW, or people fighting, and there's also fights like R or Python, what's better here? I don't mix my into this discussion, so we can just change this to a Python script. Of course, it will not run because this is still an R code, not a Python code. But of course, I'm coming prepared to this talk, so there is this trend line also in my Python script. It will look a little bit different because the code and the packages are different in there. And you will see in this case, the code is also longer. So if I just everything and paste this in and run it, then we also have a Python script now building on the visual. Very important at the very end, I always forget this, plot show, because if you run this in a Python script, in a R or Python script, visual, that's the right name. R or Python script visual, it means that the script has to return something to show, like a picture. And that's what we get here. So again, for some reason, this takes some time. A little bit unexpected why it takes so much time. And in the meanwhile, I walk you through the script. So again, there's different packages. Here it's called libraries or packages we can load. So the most important one is the sklearn for the linear model, and the matplotlib, where I then plot everything, and the pyplot, and pandas to work with the data sets. Then again, I change the data type to make sure Python, I have a good time in Python with that. And then here I really have to create a model. So I call this linear model, .linear regression, linear model. Remember, this is the sklearn. I taken from the sklearn package. And then I call the fit function or fit method or whatever for my model I just created there. So it's an empty model, and then pass in the date, and I pass in the sales amount, and then I do the prediction. So I call then again a function or method on my model doing the prediction for over the date, and I want to have a new column in my data set, which is called prediction, where I then fill in the predicted value. And then I create the plot. So in this case, it's dataset plot, having the date, the sales amount there, different colors, the style is just a line there, the figure size, so how much space is planned for that, then actually plot it. So first I create the plot, then actually plot it, and then show the plot. For some reason, it's not showing up, so I'm not sure what's the issue here. Maybe I just jump back to one which is working. At least when a few hours ago, I worked through them. This did work, but currently it doesn't. The demo got, oh, okay, here it does. So this is the same code I just used there. I don't know why it's not showing up there. So it's the same code I just walked you through, right? And it's the same data set. So I don't know why the other did not work. And now we have the same or a very similar result here. So we have this green line for the actual values and the blue line for the prediction. Does this answer the question of whoever asked for Python? And then the other thing is here is running the R Python script in the visual means even if you have more visuals, then you have to duplicate the code in here. So this is what I don't like too much about the R script and Python script visual. The second thing is, if you publish the report to the service, please make sure in the Power BI service, of course, you cannot install packages there. Microsoft is taking care of that, and in my slide deck, there's a link, actually a link to R and Python, what kind of packages are available in which versions. So make sure to have the same version of Python or R and the same versions of the packages running locally on your machine. So you see the same things and you're not getting disappointed because maybe it's not running in the service or it looks differently there. And the third thing is, if we have it in the visual, then we duplicate the code. And it's always running, so ad hoc, so it can take some time depending on how complicated your machine learning model takes time to build. I mean, this is just forecast, it's rather easy, but it could be more complicated models. They will take time to show and render the visual. So the solution for that is to have the R Python script not running inside of the visual, but as part of your data load. So if you jump over to Power Query, then you can see here I have different things in here, and there's one R integration and Python integration. So the trendline script is the very same I have here. So I have like my date, I have my sales, I have my prediction in the final outcome here. And if you take a look over there, then you see like there's several steps. So I take a source, I remove columns, rename things, and then there's one thing here, run R script. So I can run an R script as a transformation in my Power Query, which is really, really cool because you can do a lot in Python and you can do a lot in Power Query, but sometimes either you already have a script in R or Python, or there might be things which are easy to handle in R or Python. And you can run a script either as a transformation, or you could also run the script as the starting point, as a source here. And if you click this gear icon, then again, you will see the very same code running here again in R. No, I'm lying to you because in the other one I used the ggplot to do the trend line, right? So here I had to actually create this linear model. And I didn't even have to start any libraries because what I'm using here is the base functionalities of R. So I have this linear model, which is a regression. I pass in the sales amount and ask, please explain or predict the sales amount over the date. And everything you need is in this data set. So the data set is again what is coming in from Power Query. And then the output is then what I deliver them back to Power Query. And a cbind, that means column bind, I enrich my data set with this new column called prediction. And the content of this column prediction is what I get from the predict functions over M. M is my model in here. And this is what this step is then delivering back. So if we take a look here, run script, we see this step is returning then just one element here, which is a table, or which was a data frame in R, right? But this can be treated as a table then back in Power Query. And then it shows output, and then I change the data type for some of the columns and rename the columns, and that's it. This has the difference here is that every time I refresh my data model, it now will take longer because the prediction is running there. But afterwards, the visuals will be faster because they're just showing the numbers already stored in the model. So that's the difference in here. Refresh takes longer, but the visual will be faster. And if I have the visual, the R script running inside of the visual and I apply filters, this means that the visual only get the filtered rows. So also the prediction is only put on the prediction is done only on the filtered rows. If I have the values in prepared in Power Query, show this in the visual, and then limit whatever apply filters, then of course what I see in the visual is limited, but the calculation of the prediction still is the same and dependent on the whole data set. So there's a very important difference here. Are there questions, Tracy?
Yeah, I think I know the answer to this one, but I'm going to ask it anyways. Usually, how much time does it take to load the prediction chart in Python?
Yeah, as you've seen, I mean, only the one which I created took a long time. I'm not sure why, but you can see like if I click here, it's now rendering. This is the R script, Arima, really fast. If I jump over to Python, I think it's cached now, but this one might be not cached anymore. So it depends on, of course, the script or the script task. Of course, on your local machine, how many cores and how busy the machine is. But usually, for many of the things, it's fast enough, I would say, for what you get out. But it's hard to tell.
That's the answer I
if
was
you're just
going to give.
referring by this took too long for the other one. Pardon?
That's what I was going to say. It depends.
Yeah, of course it depends. But I thought that the question was referring why it took so long with this one visual, and I just don't know. So something is wrong here. I'm not sure what's actually because it's again this calendar thing here. Maybe that's the reason for that, because it should get this date. I think. Yeah, now it's running fine. Okay, so the problem was not Python, the problem was not my computer, but the problem was between my chair and my keyboard, so myself. Any other questions?
One more quick question. Yeah, are you going to share the data source in the Power BI doc?
Yes, of course. I'm happy to share this with you, so I can share it with the organizers of the conference, and they can share it with you, or just ping me directly. At the end of the session, I will show my my slide deck and again, and then you'll find my Twitter and LinkedIn and my email there, and just ping me. I will be happy to share all the content, the slide deck, and all the demos with you.
All right, that's it. Thank you.
Okay, so back to Power Query. So of course we have the same also with Python. So let's stick to just the trend line in here. So it's not getting too confusing with too many scripts showing up here. So I have also this Python script here, and this is the very same like we have seen previously, because then I also use the matplotlib. I use the linear model from sklearn, right? I changed the data set, the date here. I created this model on the linear regression. I did the prediction, and the only difference is here I'm not returning a chart, not a picture, so plot show or something. I don't have to do that, but I'm just returning the data set again here. So here I'm not just returning a different data set, but I just enrich the data set. That means the end of this step, if I see the result of this step, run Python query, is then returning a data set called dataset. And then I choose this data set and then change data types and rename some things. So same story, and then I have the prediction here. And to make it clear again, what's the difference between having it running in Power Query or in the visual is, let's jump back to the report. And I think I have one here for the which one is it? Empty time is a composition. I think this is the trend line. This could be this one or the other one. Yeah. But there's no filter. No, this is not what I want to show. There are trend lines, so one of those it is. Since prediction, trend line 3. Here we go. Here we go. That's what I want to show. So what I'm having here is I have 3 different visuals, and all of those 3 are using the sales amount and then showing, what do we have here? Only the sales amount. And then there's a trend line over, no, how is this done here? Oh, this is an R visual. So it's using the, so it's now calculating everything in the script. So this script is then returning, come on, show me the script. So this script is calculating the trend line, and it's returning a plot containing the actual value and this with a linear method, right? So that's what we're seeing here. The other one, this is just a simple R script, and it's just plotting, so it's not calculating anything. So if we look at this here, we see that this script is also using the ggplot package here, but at the end, the stat smooth is not shown because I show the sales, and I also show, where is it? The trend line somewhere here. Genau. I add another line where I show the prediction. So the prediction is now part of my data set coming into the script, and it's just showing what's there. So this is an R script visual where I use ggplot to show the values, but the values are not calculated in the script. It's just showing what's coming in. And that's what should make clear the difference, because if I do any filter on 2013, remember, inside of 2013, we have this negative trend. Overall, we have a positive trend. And as we can see, if we calculate the prediction inside of the script, you can see now this is reacting. So now it's downward. If I just remove the filter, now it will change here, both change, and you see this upwards trend, because now over the whole period, I've got the upwards trend. The other one is also showing the upwards trend, but if I click on the filter on 2013, the trend line is still an upwards trend, because this trend line is calculated during Power Query. So I'm just showing what's pre-calculated there. So this is an important difference beyond of performance. It's also the data set, or like what the model can see, what you can use then. Okay, any questions about that before I'm summing it up and before I'm running out of time?
No questions.
No questions. So let's go back to slides. That means I just want to show you a lot of slides there as promised, and there's like, they're all constantly changing, so I try to like explain it in short notice. What is the Q&A visual? What's the question and answers? And then I provide you with a link, because if they change something or add something, that might be helpful to see this, but it's maybe even more helpful to see the original blog post. And there's different things, insights. We talked about the insights, which was like explain me the increase. So this is here, the smart narrative was where it summarized everything up as in plain English. So it tells me what I can see there. Really, really cool feature. The analytic lines, different lines possible. The constant line we did for the 100% stack bar chart with the 50%. And then we did also the trend line. We did the forecast. We did the anomaly detection with the analytic line. I did not show you any of these. We talked about custom visuals. So there's a lot of visuals available there. And then we have this R integration, which can be used as a source, as a transformation in Power Query, or as a visual. And this link at the bottom is really important. That's the list of available packages in the service. So this really make sure that you have the same versions and same packages you build the visual on, like you will use in the service. And if you use R or Python in Power Query, and you want to publish this on the service and you want to refresh it there, please be reminded that this only works with the personal gateway, not with the standard or previously known as enterprise gateway, only with the personal gateway. So we have some limitations here. And in Power BI report server, the local version, R and Python scripts do not work. They're not supported there, and there's no plan to support it anytime soon. So Python, the same thing. And yeah, we did not walk you through this, so I just jump over there. You can read this afterwards. So feedback is really important. That's what the organizers asked me to show. Yes, it's important. Please rate my session. Please give feedback. And I don't know how the feedback form looks like, but if there's like an open form, open text, please write there. That's what I can learn from. If you just give me, I mean, I'm glad if you give me a good mark, but if you tell me what I did really good, I will learn more from that. And if there's something you did not like, of course, be honest and give me a better character. But please let me know what I would have done, what I would have to do to make it better the next time, so I can learn from your feedback. Otherwise, it's not really useful. And this leads me to the questions slide, where you can then take my Twitter handle, the LinkedIn email is not really there, but on LinkedIn you find all the other details then there. So I'm happy to answer questions for the last 1 minute or so, or just ping me and I can provide you directly with the files.